Hi guys, welcome back to my YouTube channel. I'm going to be doing some revision questions for vertical projectile motion like I had promised in my previous videos. So I already did a video that covered the graphs, how we interpret them, like the theoretical component of it. Today I'm just going to be doing some questions on how to interpret the graphs in the exam format, right? So if you look at these first question, this is what I always recommend, that you please pause the video and attempt by yourself to do the question before you play the entire video, so that you can sort of practice as I go and be able to gain a bit more from the videos, right? So if you look here, it says a rubber ball is thrown vertically upwards from a balcony of a building. When the ball lands on the ground, it bounces vertically upwards. The velocity time graph below represents the motion of the rubber ball, and they show you a velocity time graph. So last time I explained that it's good for you to sort of break down the entire motion into points, a point A, B, C, D, and so on, right? So if you look here, you are told the ball is initially thrown vertically upwards. So if it's thrown, it means there's a certain initial velocity, right? So it's thrown with a certain initial velocity vertically upwards, right? If I was to draw it, I'd have something like this, and then it reaches the ground, and then they say the ball bounces from the ground to a certain maximum height, right? So if you look at this, this would be point A. The ball is thrown at a certain initial velocity. This is the balcony above the ground. This is the ground. Okay, ball is thrown at a certain initial velocity at A, reaches maximum height where the velocity is equal to 0 at B, right? And then this point here would be when it returns to its initial starting point. So this would be C. And then due to time symmetry, you can see here, takes 0.5 seconds for it to reach the maximum height, 0.5 seconds for it to return to the same position, right? And then it reaches the ground at a certain point. Let's call this C. At a certain point D. Apologies for that noise. And then here in this graph, they do not show that there is a certain period or the time the ball that is going to be in contact with the ground. So they just show it as at the moment it lands, then it leaves the ground, which is realistically not the case, right? But you follow what you are given on the question. So some questions, like the one we're going to do next, will show the time the ball is in contact with the ground, right? So, and then the ball leaves with a certain velocity, leaves the ground with a certain velocity, and reaches a certain maximum height. So let's say here D, it's leaving the ground, and then here it reaches the maximum height E, right? And then they say use the graph to determine the initial velocity of the ball. So as you can see from here, the initial velocity of the ball is going to be at A, which is 4.9 meters per second, not second squared. It's going to be upwards, right? And then they say use the graph to determine the time at which the ball strikes the ground for the first time. So we already interpreted the scenario, and the ball is going to strike the ground at D, right? So the time there is going to be 1.5 seconds. Then the next question says, calculate the speed of the ball after 0.3 seconds of being thrown. So now there's equations of motion that you can use here. There's 4 of them. I'm just quickly going to write them down. So you can use the equations of motion. You can, let's pause this one and take another paper. So you can use your equations of motion, which there's 4 of them. You can either use delta y is the initial delta t plus half a delta t squared, or you can use vf squared is vi squared plus 2a delta y, or you can use vf is equal to vi plus a delta t, or you can use delta y is v initial v final over 2 delta t, right? So now the question had said calculate the speed of the ball after 0.3 seconds of being thrown. So that was question 1.2. You have the time, which is 0.3 seconds. So it's always good to write down what you have, especially like in an exam, so you don't feel like overwhelmed by all this information and the graph and everything. So you're looking at the graph from its initial speed, right? And then to the speed after 0.3 seconds. So you have delta t, your v initial, you can find from the graph is 4.9 meters per second, right? What else are you given? Your a is equal to the gravitational acceleration, which is 9.8 meters per second squared. So if you could remember from this graph, let me bring it back so you can see. If you look at this graph, you can see that up is chosen as positive. So the initial velocity is in the positive direction, which means down is going to be negative, right? So if you're now using your equations of motion, then you have to take into consideration your positive and negative directions. So it means if up is positive, then your acceleration, gravitational acceleration, is going to be negative, right? And then you can look from these equations of motion, which are given to you in the formula sheet, which one will have one unknown. Sometimes you have to calculate in using more than 2, or rather more than 1 of the equations, but usually one equation can get you a straightforward answer for 3 marks, right? So if you look at all these equations of motions, then you can see that you can use this one, the third one. Vf is vi plus a delta t. Then you simply substitute 4.9 plus negative 9.8, 0.3. You not really, you don't have to transpose. You get your final answer after calculating as 1.96 meters per second. They said calculate speed, so you don't have to indicate the direction, right? If they had said determine the velocity, then you must indicate that it's 1.96 upwards or downwards. Next question, 1.3 said, the ball loses 10% of its velocity when it strikes the ground. Calculate the height to which the ball bounces after striking the ground, right? So they tell you the velocity that it's going to reach the ground with. If you look here, it's reaching the ground with a velocity of 9.8, negative 9.8, right? Because it's now downwards, 9.8 meters per second. They say now when it leaves the ground, it loses 10% of its velocity. So you can be able to calculate the velocity with which it's going to leave the ground which is going to be the velocity that it reached the ground minus this 10%, right? So you can calculate the 10%. First, I said you calculate the velocity it leaves the ground with. Which is equal to 9.8 times 10 over 100, which is 0.98, right? And then you can just say velocity with which it's going to leave the ground. Let's just say 9.8. Let's make this a minus 0.98, right? You're going to get 8.82 meters per second. That's the velocity with which it's going to leave the ground. Now the question says calculate the height to which the ball bounces. So after leaving the ground, to which height does the ball bounce? So remember we had this. Now we're just focusing at point D to E. D to E. Those are the points that we're focusing on, right? So if you look at point D, E, then you can be able to calculate, since you have your V initial, this becomes your V initial. Your V final is 0 meters per second. Delta Y is what you're looking for. Your A is equal to G, 9.8 meters per second squared is what you always have, which is going to be negative, right? And then also your, let's calculate here. You can be able to calculate your delta Y. So you go back to your equations again. You have your final, you have your initials, your initial velocity, you have your acceleration, and you can be able to solve for delta Y. So you can use the second equation, plus 2a delta Y. So your final is 0 squared. Your initial is 8.82. It's positive because it's upwards. And then negative 9.8 and delta Y. You transpose, and what you're going to get is, after transposing and doing the quick math, you'll get delta Y is going to be equal to 3.97 meters, right? So that's the height it's going to reach after bouncing, 3.97 meters. And then the next question says, draw a position versus time graph to represent the motion of the ball from the time it is thrown until it reaches the maximum height. Basically, what I drew here, which is the trajectory of the ball, is just the easiest way for you to draw a position time graph. All you have to do is put in your x-axis and your y-axis and label it, and also put in some of the values that you would have gotten along your calculations and from this graph as well. So from this graph, if you use the ground as your zero position, since it's not mentioned, it means you can do either or, right? What do we have so far? We have the time with which it's going to reach maximum height at B, 0.5. We also have the time 1, and we also have 1.5. We also have, no, this time we don't have, but we also have the height to which it's gonna bounce, which is what we calculated as 3.97. You label your axis position in meters, and you label time in seconds, and you're done, right? Then the next question says, Let's do now a different question. Remember, we're just applying what we learned. Now in this question, you're given a ball is thrown vertically downwards from the top of a building and bounces a few times as it hits the ground. Velocity time graph describes the motion. And then they said you have to interpret the graph, obviously, and then write down what, answer the questions as you've been asked, right? So again, let's break it down so that we can simplify our lives. Ball is thrown vertically downwards. So from a certain height, it's thrown vertically downwards. Reaches the ground. If you look here, point A, right? Reaches the ground. Let's call this point B. Point B. This is your ground. Right? As you can see from this one, down is taken as positive, right? So I always said you don't pick, when you're given a graph, the graph tells you which direction is going to be taken as positive, right? And you can take the ground as your zero reference to simplify your life if it's not mentioned. So that's point B, and then the ball is in contact with the ground for some time and then leaves the ground with a certain velocity x. So this is C, it's leaving the ground, reaches a certain maximum height and returns to the ground, right? So if you look here, this is C, and then it reaches a certain maximum height where the velocity is 0d, and then it returns to the ground. Let's call this E, and then it's in contact with the ground for some time and then leaves the ground again, F, and reaches a certain maximum height when the time is T. So that's called as F and G, right? So this is basically the motion of the ball, the trajectory of the ball. Then the question says, write down the speed with which the ball is thrown downwards. So that is going to be from the graph at A, which is 10 meters per second, right? The question says speed, so you don't have to indicate downwards or upwards. And then it says all parts of the graph have the same gradient. Give a reason for this. So remember now, this is once the ball has been given the initial velocity, and now it's a free falling object after it leaves the person's hand, right? The question will usually say, which I forgot to include here, ignore all effects of air friction so that you only consider your gravitational force as the only force acting on the object. So then it's now free fall, which means the acceleration of that object is going to be constant throughout, gravitational acceleration. So now how are you going to answer that question? Just for a simple 2 marks, 2.2, the gradient represents the acceleration due to gravity, which is constant for free fall. Remember, gradient, delta y over delta x. So the gradient, for those who still don't fully understand it, delta y over delta x, which is change in v over change in t, right? Rate of change in velocity is equal to the acceleration. So that's why we're saying it represents the acceleration due to gravity, because this is a free falling object, right? And then the next question says, calculate the height from which the ball is thrown. So if you're looking at the height from which the ball is thrown, it means you're looking at section A to B, right? That's the section you're looking at. So you can gather everything you have from that section, like the information that you can be able to use from that section, and use that to answer the following questions. Right. Calculate the height from which the ball is thrown. So you can use any of the equations of motion, but what do you have? You have the initial velocity. The initial is 10 meters per second. You also have the time it took for the ball to reach the ground, which is 2 seconds. You always have the acceleration to gravitational acceleration, right? So the ball is going down was positive, if you remember, which means I can now, I'm looking for delta y, use my equations of motion, right? I can also use the one where it has the final velocity, because I was also given my v final was 29.6. So I'm just going to use this formula, delta y is v initial delta t plus half a delta t squared, right? Then from here it's simple substitution, 10 2 plus half 9.8 2 squared, and then you should get your answer as 39.6 meters, which means the height is 39.6 meters. Then the next question, this is 2.3.1, 2.3.2. Calculate the time t shown on the graph. I'm going to bring it back. If you look at the time t, it's the time for the entire motion of the ball that is represented here, right? So it means, since I have the time all the way to f, I can find the time from f to g and then add it to the time that I already have, and then I can get the time t, right? So what I'm looking for is fg, the time for that duration of the motion, right? So fg is when, after bouncing, it was leaving the ground and then reaches maximum height. So it means now I need to look at that short period. What am I given? It's going to reach maximum height, which means the v final is going to be 0 meters per second. The v initial I'm given as a negative 25 meters per second, and then the a, which is equal to gravitational acceleration, is 9.8 meters per second squared, right? And I can calculate using one of my equations of motion. I'm looking for delta t. I'm going to use v f, let's go here, is equal to vi plus a delta t. I substitute 0, negative 25 plus 9.8 delta t, right? And then from here, all I have to do is transpose. You can't get a negative time. If you get a negative time, then you know there's definitely something wrong with your directions, right? Your time must always be positive. So you'll get 2.55 seconds. Remember, this 2.55 is for the FG part of the motion, right? So you still have to add it to get the total time. You must still say 8 plus 2.55. You'll get 10.55 seconds as your answer, right? Then the next question says, write down the time that the ball is in contact with the ground at the first bounce. So if you look in your graph again, you'll see that the ball is in contact with the ground between B and C, and the time there, the difference between the time there is 0. This is not 2.4.1, 0.2 seconds, right? And then the next question says, write down the time at which the ball reaches a maximum height after the first bounce. So after the first bounce, which means from C, the ball is going to reach the maximum height when the velocity is 0 meters per second. That's going to be at D. So the time is going to be 4.995 seconds, right? So you just read it off from the graph, right? I hope that was helpful. I hope you actually attempted the questions. And then if you have anything that you want to add, feel free to do so. Or anything you want to ask, feel free to do so in the comment section. Please like the video, subscribe, and share with everyone so that you can get some assistance with your revision during your exam preparation time. Thank you for tuning into my YouTube channel.